Hey everyone, in this video I wanted to dive into the various deployment types we have with Azure OpenAI, understand what that may mean for the resiliency, the availability service, and then what I should therefore do as part of my overall application architecture that leverages Azure OpenAI. Now, one of the most important things to remember up front is when I think about, okay, I'm using generative AI, I'm talking to an Azure OpenAI service. When I'm talking to that service, there is no ongoing state. So I think about, well, there's the model over here. This is my GPT 4.0, whatever that might be. Every interaction with it is essentially a fresh interaction. There's nothing the model has to care about. So when I go and send my RESTful API with my prompt, remember my prompt probably comprises of something like, well, there's a system prompt, and then there's the user prompt. What I get back is the inference, the response they've made. So they've done some inference here. We're used to the idea of having a conversation with it. So I then send a second request. But that conversation is not being maintained at all on the model. When I send my next request, what I'm actually sending is the full context. So once again, it would have the system prompt. Once again, it would have my user prompt. I would tell it the previous assistant prompt it gave me back, and then I tell it my new prompt. So every interaction is basically fresh. The model never has to remember. So when I think of the cloud, when I think of large deployments, every single separate request I make, even if it seems to me like it's part of an ongoing conversation, could be going to a completely different instance of the model. It makes no difference whatsoever. There is zero state it has to maintain. So I want to make sure that was super clear. And if you wanted to see that in action, I did a video maybe a few months ago about AI development for non-developers, where we actually walked through and created that memory so you can see exactly how it works. So with that understood, there's no state we have to worry about. When I use Azure OpenAI, I create a resource. Now, just like everything else in Azure, when I create a resource, it lives within a certain region. So I could think about for a second, I'm just going to draw a couple of them, but you can imagine the idea that I've got region 1. There'd be a region 2. I'm not going to draw all of the regions. And then there's lots and lots of other regions that all offer services. And what I'm going to do is when I create an Azure OpenAI resource, the first thing I do is I deploy that resource to a specific region. So in this point, I'm going to go ahead and, hey, I create my Azure OpenAI resource in region 1. Could be West US 3, doesn't matter. And that Azure OpenAI resource lives within this region. And remember, it's the Azure OpenAI resource that has the endpoint. So this has the endpoint that I talk to when my application wants to send those API calls to get an inference performed. So that endpoint and that resource is bound to a specific region. If I jump over for a second, just to reinforce this point, I've got 3 different Azure OpenAI deployments, but notice they have a location. So they are bound to that specific region. And then if I go and look at one of them specifically, we can see, hey, I have model deployment. So I've got a GPT 4.0, I've got a text embedding version, but it's not the deployment that has the specific endpoint. The endpoint belongs to the Azure OpenAI resource. So at this point on, no matter what I do, I want you to kind of remember this fact. The endpoint and the Azure OpenAI resource are bound to a specific region. Nothing else I do after this point can change that very, very fundamental fact. Now, obviously, I can create deployments all throughout the world. There are loads of regions, there's loads of places I can do deployments, but the endpoint and the resource itself, well, that's bound to a specific region. Now, within the region, the endpoint and the resource is not where the model runs. If you've looked at all at generative AI, they're very greedy for GPUs. The training of them requires these massive, huge clusters with thousands of GPUs over huge amounts of time. But then the inferencing requires a much smaller set of infrastructure. When I send the prompt and it has to inference based on that trained model that it has, what the next token, the next one after that should be, well, they can run on a much smaller set of hardware. But depending on the model, it still may be many, many GPUs. So what happens here is, and this is where I start to think of this as, if there's kind of a control plane element, well, the inferencing would be more like the data plane. This is where it's actually sending the request and performing that inferencing. So in the region, what I'm going to have is many capacity pools. Now, the capacity pool will be running a specific model and a specific version of that particular GPT-4o and a specific version of it. And so you're going to have lots of different capacity pools running a different model or a different version of the model. So you have lots and lots of these in the region. And these will be made up of lots of virtual machines with lots of GPUs. Now remember, depending on the size of the model, maybe it requires tens of GPUs. So it would require multiple virtual machines to be able to run one instance. On some of the newer models, or maybe they can run on a single GPU. So I could run multiple instances on a single unit of work. But this capacity pool will be running multiple instances of the model. And the actual number of VMs that have to make that up is going to vary completely depending on what that model is. But there's always multiple instances for scale and availability purposes. And it's also going to vary, so it's going to auto scale. The actual number can scale in and out, so it adds and removes instances based on the number of requests that are coming in, the amount of work it has to do. And so while I'm just drawing the idea of, hey, the GPUs running on VMs, there's kind of a control plane element of this as well. That control plane element is looking for things like the health. Is a node unhealthy? Does it need to be rebuilt? Does a node need to be repaired? Do it have to perform scaling? So there's other components that make up these capacity pools. And once again, there's no ongoing state. So if I was working and having inferencing going on and then one of these failed, well, it would just send the request to another one. There's nothing it has to worry about as part of that at all. And of course, there's instances of these capacity pools in all of the regions. So every region offers a certain model will have a capacity pool for that particular model and that particular version. So we think we have all of these running as part of that data plane. So these are able to run instances of that model of that particular version. Fantastic. Now, there are other components that make the service work. If you think about responsible AI, well, there's a whole set of infrastructure responsible for responsible AI. So there's also responsible AI layers. That these go and talk to. When I send a prompt, it goes to the responsible AI. It's looking for, hey, are you trying to do something malicious? Are you trying to jailbreak? When the response comes back, it sends it to responsible AI to do those checks again. And so once again, those layers of responsible AI would be in every region that offers Azure OpenAI services. So it can go and talk and ensure, hey, we're not doing something bad that we shouldn't be doing as part of the solution. So we have those layers, and that's got availability and that's got resilience built into it as well. And now I want to deploy a particular instance of my model. Now, when I do a deployment, let's go and take a look at this for a second. When I do a deployment, it says deploy a new model. And I'm just going to deploy a base model. And let's pick GPT-4o. I get some options here. Now, for now, all I'm going to focus on is this global standard and standard. We're going to come back to what provisioned and batch means a little bit later on. But he's given me these two different options, standard and global standard. So what does that mean in terms of that infrastructure? So let's think back to the endpoint lives within a particular region. And then I have these capacity pools that run particular versions of particular models all throughout all the different regions that Azure supports. The option I pick here impacts where my inferencing request can potentially be sent to. So let's now broaden this out a little bit. And let's think now we have this idea of, so if this was my Azure OpenAI resource, within my Azure OpenAI resource, I then do a model deployment. And this is where it now really controls which of these capacity pools is it allowed to send the request to. So if I select standard, the capacity pool it's allowed to send it to is the one that is in the region of the resource. So we use the word standard, but it's really like saying regional. It can only send the request to the capacity pool in that region for that model and that version. So it's fairly constrained. If I pick global, well, now it can actually send it to any of the capacity pools that are hosting that version of that model type. So suddenly I have a huge number of options for where it can send that inferencing request. Now, at this point, there's something really important to understand because traditional application architecture, we always care massively about network latency. So if I was thinking about an application and a database, we care very much about how long it takes to send the request from the app to the database. What is that time for the network traffic? We want it to be super small. They tend to be very, very chatty interactions. And in terms of the overall time an operation takes, well, that network transfer time of sending the request and getting the response could be very significant. So the difference between 1 or 2 milliseconds and 10 to 20 milliseconds is huge in the overall performance of the application because the actual operation on the database is super, super fast. So it's the network time takes up most of that time. With generative AI, the network time to send the API request that contains the prompt, the system prompt, and all that stuff, compared to the amount of time the inferencing takes is minuscule. The inferencing takes a magnitude of time longer than this network time. So if this network time was 10 milliseconds compared to 50 or 60 milliseconds, in all but some very edge cases, it will make almost zero difference to your actual experience using generative AI. The time for the overall response is the inferencing time. I care way, way less about the network latency. So we have to think a little bit differently when I start thinking about these options, because historically I might think, well, no, I can't use global because if I use global, well, then my request may be now 100 milliseconds of network latency compared to 20 milliseconds of latency. It really is not going to make a big difference. When I think of the generative AI interactions, realize what's actually going to happen here, and this is an important point. So you have your resource. What you have between your resource and all those instances is some super intelligent routing. And that routing understands the current utilization of all of the different capacity pools. Which ones are really busy, which ones have a ton of spare utilization available to them. And so based on your model deployment, when your request comes in, the routing can understand, well, what are the potential capacity pools I can send this request to? So if it's standard, regional, the only one it can send it to is the local capacity pool. Then the control plane in this capacity pool looks at the individual instances and will say, okay, which one is the least busy? But I have a very small potential pool of where it could send your request. Whereas if it's global, this intelligent routing will say, hey, look, this capacity pool, maybe on the other side of the country, is doing almost nothing. I'll send it there. And then the control plane within that could send it to the least used instance. So then you're going to get a really small latency for the actual inferencing because it's not doing very much work. And so while I might be adding a little bit, 30 milliseconds of extra network latency potentially, the actual inferencing latency will be way, way smaller because it's doing way less work. So you have to think about it a slightly different way. You can't just think, oh, where is it physically on the earth because of the time it's going to take for the packets to travel over the fiber. It's a very small element of the overall time for the operation. Instead, I want to think about the wider the potential pool where my request can run, the better, because there's a much better chance there's going to be a fairly idle model instance somewhere, which will do the inferencing on my request that much faster. And so change the way we think about latency when I'm doing generative AI. Because the network latency, again, in all but the smallest edge cases, is insignificant compared to the time of the inferencing. So, long story short, I would much rather have a global deployment and this massive pool of potential places I can send my request because there's a way higher chance there's some instance that's really pretty idle right now. And so it's going to process my API request much, much quicker than maybe some of the pools that are local to me. Think about different seasonalities around the world when people are sleeping, people are not sleeping. Around the world, there's probably going to be far less busy pools compared to the one that's maybe local to where I'm running. So it's all about that potential number of capacity pools that I could use for my request. So I just have a much, much better shot. Additionally, realize it's not just about latency in terms of how long it takes. When you go and have your Azure OpenAI resource, you have a quota. And the quota is potential tokens per minute you can do, the throughput. But that's not a guarantee of capacity being available. As most things in Azure, you can get a quota, which is what you're allowed to create, but there still has to be the underlying capacity there to be able to actually start that resource or use that resource. So when I have a quota, if I'm regional, well, that capacity has to be available to get the throughput the quota is promising, but it may not be able to meet it. Once again, if I pick global and I've got this massive number of potential pools that I can now leverage, you have a much better shot of being able to utilize all of the quota, all of the tokens per minute you've got as part of that quota being available because it has this way bigger pool of potential places it can send that request. So the greater your regional flexibility, like everything in Azure, the much better chance I'm going to have of getting my requests fulfilled and having that capacity available. So in general, I'd always be going towards that global option, having that much better pool available. Overall, my request will get a better latency. It's going to take less time to process the tokens because there's going to be more less busy instances. And I've got a much better chance of actually hitting the number of tokens I want in terms of throughput because, hey, again, that capacity is going to be available. Now, there's a slight wrinkle in what I just said. It's like, oh, go and use global, go and use global. Hey, I have a data residency requirement. John, I can't have my inferencing request that's got some RAG and that I'm attaching some data, retrieval augmented generation. I send some additional data so that generative AI can work on data it wasn't trained on. I can't have my inferencing request sent around the world. I have to stay in the United States. I have to stay inside the European Union. Well, one of the things, now I don't see this currently on my screen. I think this is just coming out as we're talking. But one of the other things they are working on right now is this idea of data zones. So if I think there are select regions, so maybe these regions, and it's more than 2, there'd be n number, but maybe that's all of the regions that make up the United States. And then there's another set of regions that make up the European Union. So there are these sets of regions. So there's now a middle option available. And the middle option is data zone. So if I was to pick data zone, what it now gives the intelligent routing the option of doing, if I picked the US data zone, it could send my request to any capacity pool that is hosted inside a US region. If I picked the EU data zone, it can send it to any region that's part of the European Union. So I now get, again, a wider selection of potential capacity pools, but I'm now staying within a certain data residency option. Now, I totally get it. Maybe you're not part of the US or the EU, in which case, hey, they may not be useful to you at this time. I know Germany, for example, can actually have some more stringent requirements around the data sovereignty. EU wouldn't be good enough there. And so really you're down to then you'd create multiple instances in the German regions, or if you're in other countries like Australia, multiple Australian regions, and you do your own kind of balancing. And we're going to talk about some of that balancing a little bit later on. So these are the options I have. Standard, I can only send it to the capacity pool in my region. There's obviously a finite number of instances. It's going to have a certain utilization. Global can send it anywhere. I have the biggest chance of capacity being available and the lowest possible latency. Because this intelligent routing is looking at, hey, what's the least used capacity pool? And then when it's close, which one is closest to me? So it's still going to try and get it close to you if it can, but it's going to intelligently understand, well, what would be the overall best performance for you? The network latency is one tiny element of that. It's way more important to try and reduce the latency, the time between the tokens, so my overall tokens per minute I can push by sending to the least used capacity pool. If this is too open to you, I have data sovereignty requirements, well, then maybe I can start to use this data zone option, which is a nice thing in the middle. So this has so far all been about the performance. Now realize there's a slight availability instance here as well. So remember I talked about there's control plane elements to all of these. If an instance had a problem, it would repair it, and your request would just be sent to another instance. But there could be an entire data plane problem in the entire region. So in that case, if I'm a standard deployment and the whole capacity pool has an issue, it can't process my request. Whereas if I was data zone or global, well, then the intelligent routing would know this is unhealthy and would send it to the next less busy one if somehow this happened to be the best one for me, which it probably wouldn't be. It has more choices to be able to handle if there are regional level capacity pool problems. You get a 3 nines SLA, whatever, but in terms of what's available to you, it may be able to help. But the endpoint is still regional. Doesn't matter if I do data zone or global, the point I'm talking to, the major control for my resource is bound to region 1. So if the region hosting my regional resource, the Azure OpenAI resource, has a problem, it doesn't matter what deployment type I've picked here. If there's a problem at this kind of element, my request can't go anywhere. If my endpoint is down, it doesn't matter. I can't do anything. So then how do I handle actual what we would normally think about of global resiliency? What is my solution to that? And this is where you are responsible as part of your architecture to have a solution in place for this. Don't think that, oh, I did a global deployment or a data zone deployment, the availability is handled for me. It is not. This is about the potential places I can send my request for scale, for performance. And again, I mentioned a tiny bit of availability in this issue scenario, but overall, this is not about availability of your resource. I have to solve that. So what would I do? Well, I have to have deployments in multiple regions. So just like we would normally do with any kind of Azure resource, I want instances in multiple regions. So I would create also an instance in region 2. So I'd have resource 2. It would have its own endpoint as well. So this would be endpoint 2, and that would be endpoint 1. So they're different endpoints. But now I have resources that are completely different control planes. They're completely different resources, completely different endpoints that I can go and talk to them. So what does that now mean for the application? You have choices. So you could absolutely, in your application, plumb in, hey, there's an endpoint 1, there's an endpoint 2. Try and talk to endpoint 1 first. If it fails, or maybe you get a 429, it's run out of capacity, go and talk to endpoint 2. But now I'm putting all of the emphasis on and modifying the app. The app is used to talking to a generative AI model. Do I really want to have to go and change my app or every app? I may have many, many apps using generative AI. I have to now change all of them to understand multiple possible endpoints and how it should check them and how to check it's healthy. I could maybe stick something like an Azure Traffic Manager or an Azure Front Door that's kind of dumb in a way when I think about generative AI, but it then may give you a single name that it can go and talk to. That may be an option there as well. What most people are going to do, though, in this scenario is I would actually think about putting something like Azure API management in front of it. So I would think about having an instance of APIM, and I would make sure I pick the premium type of Azure API management, because the premium SKU lets you have instances that provide the service in multiple regions. So I would make sure it has components in multiple regions, so it is geographically resilient. And then your APIM instance would be configured with the various endpoints. So it knows it can send to that one and it can send to that one, but it has its own single endpoint that your application would then talk to. And then I could do totally awesome things with an APIM. And I did a separate video on APIM and generative AI, but it could send all of them to endpoint 1, and only if there's a problem, send it to endpoint 2. It could do intelligent stuff like, hey, I'm going to split them. It may be, and we're about to talk about this, I have a provision throughput instance, and only when that's run out of tokens do I then go and send it to a regular pay-as-you-go instance. It can do things like semantic caching. So if I'm sending the same prompt or very similar prompt, don't send it to the model at all. Just send the previous response back. It's going to save you using those tokens. Lots of totally cool things you can do. But the key point here, you have to architect for this. You have to have instances in at least 2 regions. You would then have model deployments for each of your models. Again, it could be data zone, it could be global, could be standard. It doesn't impact anything other than the potential number of pools I can send my request to. And then you would want something to provide a single endpoint, ideally for your app, so I don't have to make my app aware of this. And this is a very easy thing to go and implement. Just make sure this is geographically resilient. So I'm using the premium SKU. And then, hey, it will go and send those. So that's how I would think about making it resilient. Now, I did use the word caching here, and you may have heard about Azure OpenAI prompt caching. So what this does is, obviously, there's work. When I send in my prompt, there's some work to tokenize this as part of how the model works. So there's work there. So what the Azure OpenAI prompt caching does, if the prompt is longer than, I think, 1,024 tokens, and the first, I think, 1,024 tokens in the prompt are the same, what it can do is the second time it sees it, it doesn't have to re-tokenize it. It can use the tokenization it did before. And so it saves me some money. I think it's a 50% price reduction on the PayGo for those cache tokens. Now, the cache is local to a particular instance. The cache is not distributed across the entire capacity pool. It's not distributed geographically. It's on a particular instance. So then that does give you a slight stickiness between a particular session, if you will, particular app. It'll create a hash value for that and a particular instance. So with the caching, it introduces a tiny bit of context and stickiness between you and a particular instance. It's best effort. Obviously, the intelligent routing has to know about that and then send it to the right capacity pool, which then sends it to the correct instance. But it really is very much best effort. It's not going to impact from a performance perspective. If one of them is down, it won't fail. It will say, okay, well, I can't use the cache. It's a cache miss. And it will just send it to another one. But that's the only time there is any kind of stickiness with the prompt caching, because the prompt is local per instance. Then yes, and this is all behind the scenes to you. You don't have to really worry about this, but that's the only time there's ever any kind of stickiness introduced, when intelligent routing would potentially try and send it to the same instance if it can, just because it can help save you a little bit of money by reducing the work to tokenize the input. But in general, hey, you're just going to get sent anywhere. So I used the word provision throughput unit, and you saw it on the screen. So when we looked at the screen and we looked at our options, I talked about global, standard, and standard. Then there's these kind of provisioned managed options. And it's, well, what are these things? Well, the easiest way to understand what provisioned is to make a step back and let's rethink about what pay-as-you-go is, because that's going to impact what PTU means to us. So we had this model deployment, and we picked this standard or global, and data zone is coming. So we have those different options for the potential capacity pools it's allowed to use. But then we have this pay-as-you-go, which is the normal Azure construct we always think about. So with pay-as-you-go, I think what color to use. Just use purple. All right, so we have PayGo. I pay for what I'm actually using. So the whole goal here is it is consumption-based. I'm paying for the amount of tokens that I send to it and the amount of tokens that it sends me back. If I go and look at the pricing page and I scroll down, oh, and I've got the wrong region. Let's go and pick West US 3. There we go. We can see there's a whole idea around input and output. Ignore the PTU stuff at the moment. So I can see I pay for the number of tokens. Input tokens are cheaper than output tokens. It's a lot harder to do the inferencing than to do that tokenization of the input. So I'm paying for the amount of work it is doing. So if I don't send many requests, I won't spend very much money. If I suddenly start sending a lot more requests, if I start sending it bigger requests because I'm doing RAG and a whole lot of history, I'll pay more money. But I'm paying for the work I'm doing. And that's great. That's really good as I'm experimenting, I'm learning stuff, and that's a great thing. But it means our bill is variable. There's no fixed cost. I'm going to pay, like most cloud-based things, based on the work that I'm doing. But the challenge here is I get a certain quota. So I get a quota of the potential amount of tokens per minute I can do on a particular model, potentially in a particular region. But a quota is not a guarantee that I will be able to actually achieve that. So I may have a quota of making up a number 50,000 tokens per minute or 100,000 tokens per minute. Doesn't mean I'll get that. Remember, the greater the potential pools it has available, the better the chance I will be able to go and hit whatever my quota is and push what I need to. But if I was standard and this is the only capacity pool it can use and it happens to be busy at the time, well, it may struggle. I'm competing with other people. So I may not actually be able to hit what my quota is. Now, if I was global or data zone, there's a much better shot I'll be able to push that. But the point here is, when I'm using pay-as-you-go, the throughput is not guaranteed. I have a quota that's the maximum that I'm allowed to do, but there's zero guarantee I'll be able to hit that. It depends on a lot of other things going on. Additionally, the latency will not be consistent. So, and that's about the inferencing, not the network time. Again, we don't really care about that. But the inference, so the time to get my response to processing, so the inference latency, this again could be measured in tokens per unit of time, tokens per minute, or maybe it's the time between token generation, is variable. Because again, I'm just sending it to some model instance, depending on how many other things it's doing in parallel. The time it's taken will grow and shrink depending on what else is going on. So I get this great consumption base. I only pay for what I'm doing, but there's no guarantee I'll be able to achieve the throughput I need to achieve. And there's no guarantee of how long it will take to get that response for the inferencing. There's going to be requirements of certain applications where that is just not acceptable. I have to have a guaranteed throughput because I know the applications and what I'm doing. I have to be able to do this many tokens per minute. And obviously, latency of the responses and the throughput, they have a correlation. I also know, hey, it can't take longer than this time to do the various inferencing. And that's what the provision throughput, and I buy those in provision throughput units. That's what that achieves. So with provision throughput units, it's not consumption-based anymore. It's a fixed cost. Because I buy provisioned throughput units. This is a certain amount of throughput in a unit of time. Think about for an hour. So I pay for the unit cost. And this is where it gets important though. I'm paying for a certain number of provisioned throughput units. Let's say I buy 10 of these provisioned throughput units. If I don't fully utilize that provisioned, the purchased throughput that I've bought, let's say I only run at 50% of the potential that I could have used, I pay the same amount of money. So if I'm running these at 100% or 50% or 75%, I'm paying for what I provisioned, what has been guaranteed to be available to me. So if I don't plan this very well, if I don't do the right calculations and I overbuy massively, then I'm wasting money because I'm not using the amount of throughput I've actually provisioned. So that's really an important point. Now, the actual mapping of a provision throughput to the number of tokens varies depending on the model. It depends on if it's input versus output. There is some documentation. So it kind of gives a rough idea. So this one is talking about, hey, look, for different models, so for GPT-4o, for example, compared to GPT-4o mini, and it talks about the deployable increments of the PTUs. So I have to use 50 here or 25 here. Well, for GPT-4o, I would only get, say, a mapping of 2,500 inputs or 833 outputs. Obviously, the mini, the smaller models, they're way more efficient. So I get lots more tokens for that same unit. So it is going to vary. And really the recommendation here would be to use the calculator. So the calculator will open up the Azure AI Studio and you can go through here and give it the details of exactly what my scenario is. You can see here. So I can put in the various types of workloads I'm going to do, the number of calls I'm going to do, and I'm selecting the exact model versions. So I'm doing all of these choices and I'm giving it the different types of workloads I'm going to do. And then it would estimate the number of PTUs. It's going to help you estimate, well, what is the actual correct number of PTUs I would want for my environment? So it is a fixed cost. So you want to make sure you go through that exercise to purchase it. It is on demand. It is hourly. So I can change it, but you don't want to waste money. If I don't buy enough and I try and send the request, I'll get a 429 back. 429 says, hey, I've run out. Try again after this period of time. So it's not really an error. It's part of the design. It's saying, hey, you purchased this amount. I think they let you do a little bit of bursting potentially, but not very much at all. So if I've only bought so much and then I try to send it more, you're going to get a 429 back. That's where you could absolutely have a P2U instance and a pay-as-you-go instance. And so our API management could say, hey, if it gets a 429 back, just go and send it to the pay-as-you-go. So that would let you then do that bursting. And I talk about that in the APIM for generative AI video. But the benefit here is, well, I do get a fixed cost, potentially. But the bigger thing now is I do get guaranteed throughput. And I'm also going to get a consistent latency. So it's all about the performance and having a certain amount that's guaranteed that I'm going to receive. And it's also about, hey, that consistent latency for my interactions. That's really the focus of PTUs. I mean, obviously, yeah, the fixed cost may be attractive to me, but the goal of it really is about getting that guaranteed. I have to be able to process this many tokens to do my business. And I expect a response in a consistent manner. That's what the PTU gives me. It's not so much about a cost-saving type thing or anything like that. There is a model capacities API available that can help me go and see, well, what is the number of PTUs I could buy on different regions? Because again, remember, the capacity has to be there to be able to buy the PTU. So once again, if I'm buying a PTU and it's standard, the capacity has to exist in the capacity pool for that region. Whereas if I choose the option of global or data zone, there's a much bigger potential set of capacity pools, and I have a much greater chance of being able to buy the number of PTUs I want. So as always, the greater the regional flexibility, the greater my chance of being able to go and purchase this capacity for the hours, which is why potentially I could change the number of hours I want every hour, but there's no guarantee I'd be able to buy them. So generally, you have to kind of be careful around that. So overall, PTU is great where I need this guaranteed throughput, this consistent latency, but be super, super careful. Because if I buy this, I'm paying for it per hour. If I pick this option and then kind of forget I did it, or I'm playing around testing and I'm only sending it a few tokens, I'm paying the same amount of money as if I was maximizing it out. And I've seen this happening. People go and buy the PTU and they forget about it and then they get a bill for tens of thousands of dollars. So if I'm playing around, if I'm learning, if it's dev test, I probably want to be doing the pay-as-you-go. This should only be after very serious consideration and calculations of what is the right number of PTUs to buy, and then probably only in my production environment. So really pay a lot of attention before you go and do the PTU. Now, I keep talking about this is an on-demand hourly cost thing, and if it doesn't even run for the full hour, I think they prorate it so you pay for the number of minutes. If I have a long-term plan to use PTUs, well, I can then do reservations. And then I do get cost savings. I think it was in the pricing page, if we go back over. Yeah, so you do have the option of doing monthly and yearly reservations. And when I do that, you do save money. Obviously, monthly here, for example, is $260. The annual is $2,652. Well, that's 2 extra months I've got there, basically for free. So I can save money, and that's obviously over the price discount of what the hourly would be. So yes, with PTUs, you can absolutely save money with reservations, but you have to really know your business. Because if I overbuy the reservation, well, then potentially I'm wasting money because I've bought too many. Now, because of the discount, maybe I'm only running at times at 80% or 70% utilization, but I still overall save money compared to that hourly cost. You would have to sit down and work out, well, how busy am I? There's APIs to go and see what utilization of the PTUs I'm actually seeing. So maybe you would start off on a monthly, but you'd probably take time up front to just monitor what you do over a period of time. And then once you feel comfortable that my business is consistent in that, I could then maybe go and do the reservation. And again, I may want to go and create a pay-as-you-go instance as well to burst out if I exhaust my PTUs, if I'm trying to be very conservative and make sure I don't overbuy. So that's how I use the PTUs. I have those same options. Again, data zone is coming for both the pay-as-you-go and the PTU, and that's going to be a nice option where I do have those data residency requirements. The other thing you saw there was batch. And that's only global. So batch is only global. And the whole point of batch is, think of inferencing jobs I have that are not time sensitive at all. Maybe I have a whole lot of content generation I want to perform. Maybe, for example, I've got a whole bunch of large scale data processing. Maybe I'm doing some data extraction and analysis on that. Maybe I'm doing a huge lot of document analysis, but there's no time criticality to it. And if you think of globally, Microsoft have all these different capacity pools that have different utilization at different times of the day, week, month, whatever. What Global Batch does is I can asynchronously submit inferencing jobs, say, hey, I want this sent to an inferencing model, but I don't need it back straight away. So Global Batch gives me a 24-hour window. So I submit my job, so it's asynchronous, and then that job waits until the intelligent routing says, hey, look, this one's really not busy. I'm going to go and send your request over here. It's going to process it in its spare cycles, send me the response, and then I get the response sent back to me within 24 hours. And obviously, it's much cheaper. I think it's about 50% of the cost for me. So if I have inferencing requirements that are not real time, they're not interacting probably with some other system, some other agent, or some human, but it's just, hey, I want to get this done, but I can wait a day. Global Batch lets us take advantage of the spare capacity Microsoft has for the models globally, and I just have to wait up to 24 hours. Now, obviously, that means data residency cannot be an issue. At this time, I'm not aware that there's a data zone version of this. It's global only. So that was it. I hope this helped sort of understand what the different components and what they mean are. Realize when I do the standard versus data zone versus global, primarily it's about what are the pools, what is the size total pool available for my model and the version that the intelligent routing can send it to. So I'm going to achieve the greatest overall performance. I'll be able to push the highest possible throughput. I'll get the lowest latency because it can pick the least used one. So it helps me get the better performance that is possible. This is not really, though, about disaster recovery or availability. Yes, it might give me a little slight protection if there was some localized regional capacity pool, but your resource still exists in a specific region. And so what I need to think about is I have to architect accordingly. I would want instances of Azure OpenAI in multiple regions. And either then I'm putting the onus on the app to understand multiple endpoints and make intelligent decisions, which you probably don't want to do, which means I want to put a premium Azure API management in front of them. Then it does the health probing. It goes and sends it to the one that is available that is healthy. It could then balance them. If I have requirements for a guaranteed amount of throughput, consistent latency, then I can use PTUs for that. But make sure you really do take the time to understand your requirements. I could always combine PTU with PayGo, again with APIM. It would exhaust the PTUs. And then, hey, if I still have requests coming in, if it gets a 429 back from your PTU, which says, hey, I'm full wait, then it can go and send it to your pay-as-you-go. So you're never going to impact your application. I did a whole separate video on that. In general, the more regional flexibility you have by picking global or data zone, the overall better performance you're going to get. Overall with PTUs, the better chance you're going to be able to buy those PTUs because it's got a much greater amount of possible capacity available. For most people, If I don't have a data residency issue, just use global. If I do have data residency and it's EU or US, you're probably going to want to go and use data zone. So that was it. As always, I hope that was useful. I hope it's sort of those key points of make sure you do build in that resiliency and as part of your architecture. Till next video, take care.